Hi everyone, my name is Tharwat Hassane. Today I'm going to present one research paper in Unconventional Reservoir in Western Desert in Egypt. The paper title actually is Petrophysical and Geomechanical Analysis of the Unconventional Upper Safa Formation in Western Desert. This work actually has been co-authored with my colleague Muhammad Fathi Umran. He is doing his MSc, he just graduated last year, and doing his MSc in Reservoir and Petrophysics in Norway University. The outline for my presentation today is introductions, literature review, unconventional resources types, and Egyptian unconventional resources, and what is the objective for this research. The methodology has been done to calculate our Kerogen and TOC values and gas in place. We'll take the case study for upper Safa formations and the conclusion recommendations and our references. Here actually, if you can see here the slides, it's present the world energy consumer resource from 1990 to 2014. And if you can see here, actually this is actually by EIA, Energy Administrations. So if you can see here, actually the world consuming demand for liquid fuel is increasing every day, and also the natural gas actually also demand increasing every day. Also the renewable energy actually here as well. For nuclear it's little bit stable, increasing very not too much by passing the times, and even the coal also is stable here. So let's see what's the unconventional reservoir. This figure here actually it's indicate the conventional reservoir resources and unconventional reservoir. The conventional reservoir actually it is a reservoir which can be produced by naturally or artificial lifts, such as drive mechanisms, different drive mechanisms such as like water drive, gas cap drive, solution gas drive, combination reservoir drive, compaction reservoir drive. It's called this actually it's come natural drive mechanism. Sometimes also the reservoir pressure will be not so high enough, so we'll go to artificial lift, which is actually for different type of artificial lift, such like gas lift, saccharode pump, hydraulic pump, jet pump, or this kind of thing, CSP pump. But that means we are not doing such extra process such as like hydraulic frag or some enhanced oil recovery to come up with this hydrocarbon in the ground to the surface. So, and this is actually meant by unconventional reservoir stuff. There is some categories for unconventional reservoir such as actually shale gas, tight sand, coal bed methane, it's called CPM, oil sand, oil shale mining, same bed analysis, which is like low safety, low contrast bay, and heavy oil. And you have some other resources also for that, but this is the most popular unconventional reservoirs all over the world. We are going to focus on our study later on for the shale gas stuff in our Safa formation in Western Desert. You will hear this word Kerogen actually when you go to for the unconventional reservoirs. The Kerogen is like some organic matters which actually after that by pressure and pressure is going to be like hydrocarbon also. So if you go to subdivide the types of Kerogen, you will find like 4 different types of it. For example, the type 1, which actually it's hydrogen rich. The atomic hydrogen to carbon ratio 1.4, 1.6, and it's characterized by hydrogen index is more than 700 value. And if you can see here, this is the type 1 from this graph. This graph actually, it's y-axis hydrogen index and oxygen axis and x index, and this is the type 1, which actually it will be derived predominantly from algils. Okay. For the type 2, it's actually intermediate in the compositions from hydrogen to carbon ratio 4.2, and the hydrogen index actually is ranging to 600. If you can see here, actually here, you go to the y-axis, you find like 600 value here. For type 3, which is have it here actually, is hydrogen poor, hydrogenic is poor, and the ratio for hydrogen to carbon ratio is 1.3, 1.5. Okay, and this is mainly derived from cellulose and lignin derived from higher planets. This is the type here. And the type 4 actually is hydrogen poor and oxygen rich, which is this one here. For unconventional resources estimates, some people did some research and they come up with some estimates numbers. Events in 2010 stated that peak productions will be up to 88 million barrels per day in 2084. Energy Information Administrations, which is EIA, in 2013, they stated that oil shale are estimated to be 2.8 trillion barrels. Gas shale estimated to be like 16,000 trillion cubic feet in place. Tight gas sand are estimated to be 7,400 trillion cubic feet of gas in place. Just to let you know, one information is that 1 TCF enough to heat 50 million homes for 1 year. Now let's focus in Egypt a little bit about the industry activity of Egypt. So mainly actually the industry activity in Egypt mainly depends on the oil and gas sectors. The petroleum industry is covering 94% of primary energy requirements. Okay, and this graph actually here showing the Egypt energy productions, okay, by the years starting from 1971 to 2015. If you can see here, the most of the two items produced Egypt is oil and the gas. This is the oil and this is the gas, and something a little bit of the coal and something from the hydro. But actually this is up till 2015. Nowadays, actually up till nowadays in 2018, our productions from hydrocarbon oil is almost to 670,000 barrels per day, and the gas actually production it's reaching now 6.6 PCF per day, which is very good indicator, and might be increased by second quarter of 2019 to more than that after. And actually this contribution is coming from the oil field, which like have a reserve for more is actually 13 TCF, and the other actually fields coming is called Noor, maybe within 2 months will be announced very soon about it. It will be actually add more reserve to Egypt gas. And this actually all this contribute to Egypt to be like energy hub in the futures. And now actually nowadays we are reaching to self-sufficient for gas production as well. Now let's go for some geology map. If you can see here actually for unconventional reservoirs, which is represented for the black shales in Egypt, it is actually through two different geological ages. One is called Upper Cretaceous Campanians and the Lower Mesozoic Black Shale. And these deposits are distributed through major regions in Egypt. The first one actually is called Qusseir Safaja region in the Red Sea, was somewhere here in the map, and Abu Znema in South Sinai, which is somewhere here. okay, and actually Isna Edfu along with the Nile Valley, something where here, and Kharga and Dakhla in the lower western desert, which is actually somewhere in this area here. So this is the main three zones which actually it will be contributed to unconventional plaque shale in Egypt as well. Okay. Some people actually did some sort of studies before and we'll get some numbers about the estimates for this kind of barrel in Egypt for unconventionals. For example, Shafi 2012 and DEA 2013 estimated 11.5 billion barrel of shale oil, reserve of shale gas up to 100 TCF, and the tight oil 4.6 billion barrel reserves. Actually, and you can see this actually once all this produced will be actually change the transmission to Egypt energy market for sure. Now let's see our research will be focused on what. Actually, our research will be identify the potential of shale gas by different methodologies such as the logs or geochemical data from the lab, determining some sort of valuable information about the unconventional reservoir origin, like fluid in place, gas in place, level of maturity, and integrate that with the core data as well. Integrate the unconventional reservoir parameters such as porosity, permeability, roughness, observation type of Kerogens. Get more accurate and reliable approach for unconventional reservoir. Estimate empirical correlations. Actually, we are going to get actually out of this study as empirical correlations between the volume of Kerogens and the total organic carbon as well. And we're going to estimate actually empirical correlation between the absorption gas in place and what's called AGIP and the TOC, which is total organic content in upper Safa formations. Research methodologies. Actually, some experiment laboratory reports has been actually created and given, and we are going to integrate that with the open hole log data. Geochemical analysis will help us to get the Kerogen type using pyrolysis analysis, level of maturities by giving Vitronite's reflections coefficients, total organic carbon content using base equations, and actually NMR and Schmoker and modified Schmoker methods. Hydrogen index directly depend on the hydrocarbon density of the gas. We'll get actually this from the gas specific gravity. We can get the hydrogen index from one relationship there. Okay, so the methodology, as we mentioned, metaphysical analysis will do it by using the log interpretation analysis for the gas, total organic carbons, estimation volume of origin in place, which is the gas volume in place, total organic gas in place estimated with the concentration volume of gas absorption. And we can also touch the rock mechanics to get some elastic moduli for the upper Safa formations and get the Bretnitz ratio, which is indication for the help us to get right hydraulic frac feature to reduce this kind of shale gas. If you go to the explain the geology for the upper Safa formations, it is actually located in the Jurassic geological age at the western desert region, and you can see here this is the geological column for Egypt and western desert, and this is the zone of interest. Actually here we're talking about the upper Safa and Khatatba stratigraphies, and it is considered as a source rock of hydrocarbon gases. This reservoir actually classified as a complex field with huge uncertainty, especially in permeability distributions. As I mentioned, upper Safa formation is the subunits of Khatatba stratigraphic column, which is actually presented here in the figure below. To do the petrophysical analysis for this reservoir, we have to identify some sort of parameters, as we are dealing with conventional shale reservoirs, so we have to get the parameter for this reservoir to do quanti-lan in that. And if you can see here, the first one is the relationship between the true resistivities and the acoustics. Here actually is the shale, and here is actually compressionals, so you can get the value for the shale, for the RT and the delta T in the shale. The second graph, relationship between the neutrons and the rho B, and you can see this highlights is the shale place, so you can get, if you go here, you can get N5 shale and rho B shale. And the third graph actually it used to identify the clay type, which actually relationship between the y-axis the thoriums and the potassium is the x-axis from the spectral gamma ray, and you can see actually the dominant clay type in this case is the kaolinites with some mixed layer clay as well. By using this value, we take the logging like neutron density, resistivity, and the acoustic sonic compression in this case, and with our model, which is like shale sand models, and with Mn values, we can get actually the volumetric analysis for that, and we get the saturations and the volume of clay and the volume and the porosity and saturation as well. And from this analysis, you can see actually this is the potential price for the shale gas, and it will be good place for the hydraulic frac to get this gas out of the reservoir. Now we are going to touch the rock mechanics analysis. So by using actually the compression and shear from this I2 has been run in this field, and the volume of clay and density, we can identify some moduli, which actually here in these slides, like Poisson ratio, shear modulus, shrink modulus, bulk modulus, and the bulk compressibility according to this equation. If you can see from these equations here, it's mostly depend on the shear compression and the density, and also some sort of the volume of clay as well. By computing this using this relationship and the data, we are calculating the Breitness ratio, which is here actually according to this equation, and this is actually all the modularized outputs from our upper Safa formations. By using the PR ratio, we can actually help us to select the potential of hydraulic frac design to get to enhance the productivity for the shale gas and get it out of reservoir to the surface. Here actually the geochemical logging data, which it can support us to identify the Kerogen types, and if you can see here, this is actually here the depths, and this is actually the hydrogen index 2S2 and 2C, and if you can see here, this is the area of data which actually present and confirm the Kerogen type. Here is the Kerogen number 3, and here actually the another graph which I explained before, but our data actually here it is present in the Kerogen type 3. This one actually it is help us to get the maturity level LOM by using a Vitronite reflection factor. We use 1.5 from all the studies, and by using this chart here we can get the level maturity is 12 here as well. So this is actually by using this value, and it's using this value and calculate the TOC from delta T log R space equation in this case, and by using the hydrogen index value we get a relationship between TOC and the level of maturity, and they found it is actually 2.64, which confirm with the value from the TOC from the pyrolysis analysis and the core analysis, and actually it is 2.5 almost from 0.75 to 2.5, which confirm our analysis from the other methods by other data in the software, the TOC log. What I have used to calculate the TOC value, we use different methods like Schmucker, modified Schmucker, NMR, and PASI. And the conclusion out of that, we found actually the three methods, which is like Schmucker, modified Schmucker, and NMR. It's already very close to each other, but PASI equation actually it is not comparable with this kind of a data in upper Safa formation in this case. We use after that go to calculate the gas in place by using the software actually, and take a look as well, and this is the output result from the software. Found is the free gas in place like 5.07 PCF, and absorbed gas in place is 6.56. And if you can go to calculate the total gas in place by sum up both of them, it will be like 11.83 billion cubic feet PCF in this case. Here is just one example to show you the result for outputs to get from the quantity length with the porosity and the saturation and kaolinite volume and the sand volumes by using the quantity length as well, using kaolinite in the modeling. And this slide show actually we get a relationship between the Kerogen volume and the total organic contents, and we found it is actually here. Y-axis is the volume of Kerogen and TOC is x-axis, and found very linear relationship between both, and here is the value of that. The same things happen for the relationship between the absorption gas in place and the TOC, and I found this relationship here because sometimes by passing the time and the pressure will be decreased, this kind of gas will be liberated from the reservoir, so we can get a good relationship between both, and this relationship actually here as it's written in the slides here. So the conclusion out of this studies for the upper Safa formation is that upper Safa formation actually it is a shale gas and conventional resource of clay. Upper Safa consists of mainly of kaolinites as the clay types, which has been used in the analysis, and some little bit mixed kaolinite types. Geochemical pyrolysis analysis is used to confirm the presence of Kerogen type 3 as explained before in the slides. Okay, and has been used different types of TOC calculations, and the found basic equation it will be not fit in this upper Safa, but NMR and Schmucher and modified Schmucher it will be okay for that. And the found the TOC ranged from 2 to 4, which will indicate it's a shale gas unconventional reservoir. Recommendations by using actually the PR and to get the brightness value, it will be good designs to the hydraulic frac for futures if to enhance this productivity for the shale gas. Basic equation it will be not applicable for this, so we have to use other methods as I mentioned, Schmucher, and TOC, and also there is something called uranium methods as well. We can also get the rock typing later on the gradations by using this value, and actually this is done already but in separate actually paper and research paper, and has been presented actually in Sydney, one of the conference in Sydney as well. This is our references, what has been references taken to help us in this studies. And this is our biography, myself and my colleague Muhammad. And if you need any data or any information about that, you can contact us through the LinkedIn, which is already presented in these slides here. And thank you for your listening, and I hope I add some value for you in this presentation.